Thank you all for being here. So today I want to talk about something that has been generally changing how I work, saving me a lot of time, and helping me do things in parallel, using AI agents to automate the repetitive parts of ETL. And I'm not talking about the fun architecture and modeling stuff that I still want us to keep doing in the longer term, but I'm talking about the things that take our whole day, which sound simple, but they're not actually that simple. They're urgent, but they take a long time. The production tooling that Indrajit touched upon in the earlier keynote. Before we get in the weeds, just a quick intro. I'm Himanshi. Like majority of you, I'm a data engineer, and I work at AWS. I handle marketing data. My team maintains MLOps data pipelines that helps business make key decisions. And like most of you, I spend a lot of time writing SQL, Spark, and explaining to stakeholders why some numbers on a dashboard changed by some percentage. And yeah, this year it will be a decade since I've been in this space, and it's been a journey working with different kinds of data domains. What I've observed is that irrespective of what domain we're working with, there are some problems that last and they're persistent, and this might be the time that we finally have an answer to solving those problems. So let's try to understand the problem at hand first. There are so many tasks that look simple on an intake ticket, like adding a column, using a filter condition, or doing some impact assessment of how an upstream data set is going to make an impact to your data sets, or just updating a derivation logic for a metric. These tasks sound really simple on paper, but they also tend to come in with urgency. So another team could be waiting for your data set for you to update that data. A dashboard could be showing incorrect data for 500 people who are looking at that dashboard and giving leadership wrong insights. And a director says, I need this by end of day today. That's the infamous. So you're trying to do careful, important work under time pressure, and that's what makes these simple tasks difficult. And honestly, the code update is actually not that difficult. That's actually the least amount of time that I spend doing. But what takes time around is everything that we have to do to make sure that the change is applied in every script that needs it. And we have validated the downstream data sets that make sure that after your change, the data doesn't break. Something else that you were trying to not change has changed. Or running things in a development environment before actually proceeding it to production so that, that there are no surprises in prod. And juggling all of that while you're attending stand-ups, getting Slack pings from your coworkers, and sessions timing out in our systems, context switching back in is really difficult, and that is the problem. So let's just take a quick pulse check on the room. How many of you have had a simple 2-hour task take a really long time and take up your whole day? Yeah, that's a lot of you. I relate to that. And the last one, how many of you have had an AI-assisted ETL change go through multiple rounds of fail, fix, rerun before it finally worked and you got to deploy to production? Yeah, that's what we're talking about. What if that loop didn't actually need you in it? That's what we're going to look at today. So what if you had some trustworthy assistants that would be really diligent assistants who never get distracted, keep all the context, and are very patient to wait for hours for your jobs to finish? You don't have to babysit your pipelines. They will do it, and you're still the one who makes the decisions and reviews their code, they reviews their work, and finally you're the approver. You can delegate the mechanical parts of it, and you're just the decision maker. You're just deciding what this agent has done is right or wrong, and then give it feedback, let it fix again. So this is the difference between one-shot prompting on an LLM to having a full workflow where the agent kind of does your whole work for you. This will execute the full workflow, so it modifies the file, it deploys it, it runs the validations, it checks the DAGs, whether it has failed or success, was it a success, and then it only asks you to review in the end when all of those checks have passed. So yeah, what does it need to know? This sounds really good, but what does it need to know? There's a lot of stuff that it needs to know. Basically, what does it need to know to operate within your system? There's a lot of things that you know, and you have to tell that to the agent. So the most natural approach to using this AI agent is in your IDE, that's how you operate, right? And this is going to be working autonomously within your stack through the same interfaces that your team already uses. In my case, since I'm at AWS, I use the Kiro IDE agent, and it performs all the actions using the AWS CLI. So it just effortlessly executes all the AWS CLI commands to do the things that I would do on a console, or I would run the CLI commands myself. So every action that the agent takes is a CLI command, and that includes deploying scripts to S3, triggering a DAG, pulling logs from CloudWatch, and figuring out why things have failed, what changes you need to make in order to make it run. And some commands that you would run manually through the console, it would just do it through the IDE. And at the end, you just have to see, you have to verify its work, and you are going to check the code. And so what all does it need to know? It needs to know the ordered sequence of steps, which role it should assume to do that. The role is the authentication that will happen. So you can set permissions on that role so that the agent doesn't actually go and touch things that you don't want it to touch. So that's how you set your trust boundary. Which environment it needs to deploy to, how's your repository structured, what are the naming conventions that you follow in your repository, which log group to check for the compute, for storage, for the DAG, all of that, and which validations to run. That's the most important thing. We know what change will need what validations, and that's what we want to give to the agent. So here's the full loop. This is what I like to call a self-healing loop. Every step you see here is executing a CLI command, and assuming the IAM role, it performs within the boundary that you have set for it, and it might look a lot on one slide, so let's walk through each one of them. So it starts within the IDE. There's 3 main files. I'll go one by one. I'll start from the bottom. The first one is the spec. So this is the runbook that your agent follows exactly. You tell it, verify the data, verify the script, deploy to S3, trigger the DAG, validate, create the CR, everything. That's where this goes. The second is the steering file. So this is your team's standard coding practices that you have to follow. This is all the tribal knowledge that you have in your mind. And this is kind of the memory that you want it to retain while it's doing its work. And here I'm also feeding it some common error patterns that I wanted to follow and that I wanted to stop at when I know that, okay, this is something that the agent is not going to be able to solve, and I wanted to come back and report to me. And then the third one is the task input file. This is going to change every time you do a new task. So you describe what you need, like adding a column or fixing a join or making some change in the derivation logic. That's what you describe here. And you save it. That saving action is going to be the trigger, and that triggers the whole workflow. And that save is where the agent takes over, and it goes through the full loop. So once it's triggered, the next step would be that it would verify that the columns and the source tables exist in your databases. In my case, it's Glue, but it could be Redshift, it could be any data storage that you're using. And if the column isn't there, it shouldn't touch anything. That's the guardrail that I have set. And then it finds and modifies the script locally in your IDE, and once it has done the modifications, it would sync to S3 so that it can trigger the DAG. And this order is important. It should verify first, then modify, and then deploy. That's how it would work. And then after deploying, the agent would trigger the Airflow DAG. It could be using an Airflow CLI or a simple Lambda. It could be however you want it to be. And then it also starts on monitoring the DAG. This is something that I would be doing manually if there was no agent. But it just keeps on monitoring the DAG with exponential backoff strategy. It would start with 2 minutes first, go 5, 10, 15, and go up to 60 minutes. Because some of retails, let's be honest, it takes time to run. And you don't need to be watching with it. It will just do that watch, and it will only stop when it has received a success or a failure signal. Now, once the DAG has failed, the agent will pull the error logs from CloudWatch, and it will check why it has failed. And I have fed some common errors that I think it should handle, it should auto-fix, it should try to handle. But there are some errors that I know that it will need my help with. So I don't want to be going rogue, and that's where I have put in an error classifier. So common fixable errors could be data type mismatches, missing columns where there's data in the source table, but it's just not present in some of the scripts. It could get fixed automatically, and the agent should try to fix it. But things like permission denied, or a memory issue, or data doesn't exist, it should come back and tell me that, hey, this is not there, so you should change your input file and modify the task or think differently. And this is what we want to do. We don't want it to just guess or do things that it's not supposed to do. And then once the DAG succeeds, we let it run some prefed data validations. That's where we start trusting it, because even though it thinks that it has a successful DAG, if it has a successful data validation, we know that it has done the work that it needs to do. And it would compare the production data with the development data and see where the difference is, and has the change been done or not. If the validations pass, it would do a code review. It would send a code review, and it would add me as a required reviewer. And if the validations have failed, then no code review will be created, and it will go back to the step where it needs to go back and check the code that changes that it has made. And that's it. That's the full loop. Every step is just a CLI command that the agent's going to execute, but you just have to define the order in which it happens. So earlier, I talked about an error classifier. Let's talk about why I added that. So story time. Once upon a time, there was a DAG that I was working with. It failed. And it failed with the column does not exist error. The agent checked the data source, and it saw other columns that were present in the table. It just saw a similar looking column, and based on that similar looking column, it assumed that, oh, this is the column that probably I wanted to add, and it used that similar looking column to fix the whole code. But only I knew that that column had DQ issues, and that was wrong. That was not the right choice. So I wanted it to ask me before making decisions like this. And that's when I added an error classifier, where I just ask it to ask me in things where it has to make decisions which I don't want it to make. So ambiguity is the line. I don't want it to take decisions where things are ambiguous. I'm okay with trusting it with complex stuff, but ambiguity is where I draw the line. So how do we make sure that the agent is doing things nicely? How do we observe what it's doing and with transparency? This is what you're looking at is an actual paper trail from a real run. So every step is time-stamped, and every decision that the agent has taken, every reasoning call that it has taken is logged in this file, including the failure, the classification, the fix, everything. And this is going to be part of your steering files, where you require the agent to log each one of its action. So at a time where it has come back to you and stopped and said, oh, I need help, this is what you look at. You don't go back and check your console. You don't go back and check CloudWatch logs, but you just go look at this log. And this will tell you everything that has happened behind the scenes. So if something goes wrong, you'll just open this. And there are some guardrails as well, which I've added. So I'm asking it to not create a code review if the DAG is not successful. And it should also not create a code review if the validations were not passed. And it should never do a DML operation. That's my guardrails. So now I would like to leave you all with some takeaways. The central theme is that every AI system that we have has two parts. There's a generator and an evaluator. The generator is actually the LLM, which is probabilistic. It's allowed to be creative. It's allowed to make mistakes. And the evaluator is deterministic, and it has to check the generator's work. So these are the two most important fundamentals. And if we define these two fundamentals in our system, it will enforce clarity. The most important learning that I've had is we have to know what will fit in this automation framework. There are some tasks which will fit very nicely, which are repeatable, verifiable, but there are some tasks where we cannot create this kind of a system for the agent to just run by itself. And our systems are messier, our data is even messier, so I wouldn't try to automate everything. I would just start really small. The trust boundary is for us to define. The bottom line is that it should act only when the fix is deterministic. It should not do things which are ambiguous, and that's where I draw this line. We should also not underestimate the setup. It takes time to write those context files, and it has to get to a point where the agent gets autonomous and is able to do what you actually want it to do. You have to earn the trust, treat it like a new team member who knows things and is starting to just work on things, and you have to get it to where you want it to be. And finally, the context drift is real. It's possible that your code repositories change with time and your context doesn't. So you should set up some ways where if your code has changed, then you update the context as well. So I hope that this context drift problem is something that we get to solve now. With the new tools that we've had, this is something that the industry has been sitting with since years, and it's been a really difficult problem to solve. With that, I would like to thank everyone for being here, and I hope something in this was useful for you to take away. And here's my challenge for you. Just pick up one repeatable ETL pattern and document what it does, and that's all your agent needs to know. And this is your starting point. Now I'm happy to take questions.